Good morning to all. I am Moustapha Amadou Roufaï, the lead of Omdena Benin Local Chapter. Today I'm going to present our project on applying computer vision for red blood cell classification to diagnose sickle cell disease. We do this project because sickle cell disease is the most common genetic disease in Africa. It is a real health problem in Africa. Over 1,000 children are born with sickle cell disease in Africa daily. And it is very difficult for African population to access medical diagnosis. And the most common biological diagnosis of sickle cell disease is called electrophoresis and is very expensive for African population. And even sometimes this test is not available in a remote area, such as, for example, some villages which are far from the main town of the country. To be able to do this project, we have collected some data. Our data are some images that we collected, clean and annotated. And there are images for blood smear obtained from two sources. Our sources are erythrocyte IDB. Here is the website. And from all the work done by the person who are seated here, and the project is about weekly supervised deep learning approach for detecting malaria and sickle cell disease in blood film in 2020. So we collected those data and form our data set after cleaning and annotation. With our data sets, we built a model, and the model that we created is able to diagnose sickle cell disease. How the model is working? Our model to work needs an image of blood smear. We give this image of blood smear to our model, and our model look at the image, identify the red blood cells, and classify the red blood cells according to their shapes. After doing the detection and the classification, our model is able to conclude the sickle cell status of the patient. It means it is able to say if our hemoglobin of our patient are AA, AS, SS, AC, CC, or AC. Here is an example of the prediction done by our model. He took the image, identify the cells, and classify the cells, and do some statistics to be able to diagnose the disease. And the aim of this model of the project at all is to decrease the cost of sickle cell disease diagnosis, because we don't need any chemical reactive, we don't need any chemical solution, we don't need any costly apparatus. We need only the images of the blood smear, and we need a computer or a smartphone to diagnose the illness. And our second aim is to make the diagnosis possible in a remote medical centers, because in a remote medical centers with minimum investment to have a microscope and smartphone, we are able to diagnose sickle cell disease using our model. I present here a demo using our model. Our model, based on our model, we build an app, and the app is now deployed on Streamlight. But it's possible to deploy this the same app in other platform. Here is our URL, the URL of our app. So we see what our app resembles to. We upload an image. Here is an image of a red blood cell. Our model look at the image and give this one image, which is the annotated image given predicted by our model. Based on this prediction, our model is able to count the number of overall cells and to count the cell according to their classes. We have 5 classes: crystal, normal, other, sickle, and target. And for each class, our model is able to count the number of cells and to know the percentage of this class as compared to the whole number of red blood cells. So with this table of proportion, our model is able to deduce that here the status of our patient. Here we see that the table, which has been written as conclusion, contain the rate of hemoglobin A, the rate of hemoglobin S, the rate of hemoglobin C. Here we have 0.84. It means 84% of hemoglobin HbA, 16% of hemoglobin S, and 0% of hemoglobin S. And the status of our patient is AS. That's how our app is working. It is rapid and it is accurate. We just give the image, and in the second, our model gives the status of the patient. So when doing this project, we learn something about the collaboration. We learn that it is very critical to use collaborative annotation tools. What we have done is using different annotation tools and trying to gather the annotation at the last time. We have some issues, but we resolve the issues, but it will be very hard for us, and it give us some extra work to do in order to finalize our project. So in our next project, we will use collaborative annotation tool, in which the members are going to annotate the data set in collaboration. What we can do next, it is we recommend to extend our model, to extend our app so as it could be able to predict the level of pain. We know that in sickle cell disease, the person have some crises, and sometimes they have very, very hard pain. So we recommend to extend our application so as it could be able to predict the level of pain. Knowing the level of pain, the medical practitioner will accommodate the medicine, the amount of medicine, and the type of medicine that he is going to prescribe to the patient. And we recommend again to extend the application to be able to predict the severity of anemia during a study. We know that this ill is coming with anemia. So if we know the level of anemia, we will know which exactly action we will take in order to to correct, in order to stop the pain, in order to stop the crisis. But I will not conclude this presentation without uploading and saying very big thank to our collaborators who work hard from the data collection, annotation, from the exploratory data analysis, from the model deployment and the model development. I thank everyone in his area and for their contribution. Thank you.